Welcome to my presentation. I'm Peter Prickarz. I'm a tech art student at Breda University, and currently I'm doing my graduation internship at Hangar 13 in Czechia. I'm going to talk about the Polyline creation tool that I made for the SIDEFX LABS Tech Art Challenge. And particularly, I'm going to be talking about making a viewer state focused tool, some decision making in the process, and some tips on how to handle a lot of user input data from a viewer state. So what is a viewer state? So simply said, it's interactive viewport UI and then the scripting of that. What does it get you? Well, it can often be a lot more efficient than a classic parameter interface. And that is simply because in 3D, it's often more simple and interactive to set up parameters. So a simple example would be if you want to have a spline and change values along that spline, you could do it in a parameter interface using ramps, but that is often not the easiest and most intuitive way. And it's a lot simpler to do it in 3D. And that also brings you a lot of low-level access because it's so easy to change a lot of values. It's not as much work to change a lot of low-level parameters. So in this example, you can change parameters on every single point, whether it's icing or gingerbread. And that also comes with a lot of art directability. So if designers or artists want to have a lot of control over something, either because it directly affects gameplay or simply because they want to change how it looks to every little detail, that gets enabled by viewer states. And lastly, it's also just fun to use. You want your artists and designers to have fun using your tools, so they stay motivated and do a lot of good work, right? And then the other thing you can do is you can put guide geometry. So that can either be visualizing a complex process. So for example, if you project geometry onto something else, you might want to visualize that in the viewport. So a tech artist who's using your intermediate tool understands what's actually going on. Or you could just preview later results. So for example, if you work on LODs, you might want to be able to see the transitions between them in the viewport by just moving your camera around. So a few examples here from the past. This is from a second-year university racing game. And basically, we just needed to be able to change banking and the width of the track and also added intersections. So we decided against using Unreal splines and instead used Houdini curves and then a viewer state to edit these attributes per point. This is another example, and this is a cave and mineshaft generator from a third-year game project at university. And basically, this is just a spline tool that supports intersections, and there's some attributes for how much wood should be in the mineshaft, how big should it be natural or man-made. Those kind of things are easily editable per point. And because of session sync, it's also really fast to bring these in engine, and you can have iterations really quickly. So those were two examples of where I used them in the past. And I didn't want to end up recreating a spline tool every time I make something similar to this. So for the Tech Art Challenge, I decided to make a generic version, basically, of this. So the Polyline creation tool, on the surface, it's more or less a simple spline tool. You can create points, move points, delete points, split connections. You can remove connections. You can make intersections, all that kind of stuff. Basic, simple spline tool features. The big magic comes in here by creating these custom attributes. So here you can see that I create an entry in this multi-palm, and then I give it a name, and I can set a default value. And also, if it's an integer or float, I can change the slider range. And as you can see immediately in the geometry spreadsheet is that I immediately have this attribute or the output of this HDA. And right now there's no point selected, so nothing happens here. But as soon as I select a point and then move this slider, you can see that the value changes in the geometry spreadsheet. And you can also select multiple points. And then as you can see, it changes the values on these multiple points. And you can choose if you want to only edit the active point or if you want to edit all selected points. So that's the difference between the yellow and the orange points in the viewport. And here I show a second example. So this is a string and not a float. And I also can give it a default value. And then once I hit update UI, I can change these the string value per point. So as you can see here, I change it and it changes in the geometry spreadsheet. And yeah, that way you can edit these attributes on a per point basis, and it gives you a lot of control over the generator that comes afterwards. So as a simple example here, I have this tree generator. So as you can see, I'm just creating a spline here on this pig head with primitive snapping. And these are basically like roots going down the pig head. And now I'm creating the tree itself. And once I cook the asset, you can see it places these trunks everywhere. Now, after I toggle the leaves on, it starts generating leaves. And also on the roots here, I changed their type to root, and I changed the P scale a bit. And here I just add a new branch. And that way I have a very customizable tree. Now, it's not very beautiful, but I hope it gets the point across of how much customizability you enable with this and how fast you can set up some generator input, but still keep a lot of control over the result. This here is a second example. So this goes a bit back to the racetrack generator. So because of that, I wanted to be able to change up vectors in the viewport interactively. And I decided to go with like a look at functionality. So basically, if you have a vector custom parameter on your HDA, you can select that, and then you are able to change that vector parameter with this handle that works like a look at thing inside the viewport. So how does the data, how do I handle the data in this tool? So basically, all the points are stored in a multipalm. So as you can see here, there's the points multipalm, and it just contains the position of the points. And then there's the connections multipalm, which just contains the connection between the 2 points. And these are shown here as the IDs of the multipalms. So the parameters inside multipalms, as you probably know, they're called, in this case, PT pos 1, PT pos 2, etc. Now, this is a bit of an issue, because let's say you have a connection between point 5 and 6, and then you remove point 4. Suddenly, point 5 and 6 are point 4 and 5, and everything afterwards shifts as well. So if you were to actually use these IDs to handle the data, you would need to shift IDs very often. And probably at some point, if you have a big multipalm, you would need to edit hundreds of entries every time the user deletes a point somewhere. And this isn't really the most stable setup. So what I did is I used UUIDs. So as you can see here, there's actually a hidden parameter, and it stores a UUID on each point. And then the connections are actually just 2 UUIDs. So these are the 2 UUIDs of the points that are connected. Same for the selected multipalm or the active point. That's all just saving the UUIDs of the points. And then in the actual HDA, you can see that there's a bit of VEX code that just creates the points and then sets the UUIDs so that later I can always use the UUID to retrieve values from the parameter interface. And that's exactly what I'm doing to set up the custom attributes. So at first, I wanted to put them inside the point multipalm. The problem with that is that multipalms have some performance problems inside Houdini. It's fine up to like, I don't know, 100, 200 instances. But at some point, multipalms, well, the interface itself becomes very slow when you add too many multipalm instances. So what I did is I instead saved the values in JSON. And this is basically just a dictionary that saves the UUID of the point and then the values afterwards. And that way I have a very easy time to retrieve the values later. So that's what you see happening here. So basically I'm just going through the custom attributes, and I then go through all points. I look for the UUID in the dictionary. If it's there, I take the value and put it in that attribute. If it's not, I take the default value. On the UI side, this all works with spare parameters. So it's not actual parameters on the HDA. What I do is, as soon as the user hits update UI, I read the values from the Palm setup, and then I create these spare parameters automatically and set callback functions on them. So when the user changes the value, I can automatically update the JSON. And this also works when saving the HDA. Basically, you might lose these the spare parameters if you save it in Unreal Engine, for example. But as soon as you hit update UI, you get them back. And because all your data is actually saved inside the JSON, it's no problem if these spare parameters go missing. Now, as for code structure, I use the Python module a lot. So basically, whenever I had any function that I ended up using multiple times, I would put it in the Python module. And that has a few big advantages. On one hand, the viewer state is just a lot cleaner if there's less functions cluttered there, but also you're able to use the functions from the Python module in multiple places. So you can call them from within the parameter interface, you can call them from within the viewer state, and you can call them from within Python subs inside of the HDA. So I would always recommend put everything that you can put into the Python module in the Python module, and only keep things that are directly related to the user interface in the viewport inside of the viewer state. So a bit of a recap and a few tips. So basically, I think viewer states are really great for keeping art directability on complex tools. They allow having really complex parameter setups that you'd never be able to set up by hand. Is you would never want the end user to click through hundreds of parameters and adjust them, but it's very easy to generate data for hundreds of parameters when the user interactively works in the viewport. One thing that I haven't showed in the presentation, but is really important, is adding a manual recooking option. And that is because you don't want to make tiny changes like move a point around and have to recook the asset afterwards multiple times a second. At some point that just becomes too slow. So I would always recommend adding a manual recooking option for that purpose. And that way, if you do it, for example, with a stash node on the output, you can still keep the guide geometry updated in real time, but not update the output. Now, make your own ID system. So whenever you want to describe relations between multi-palm entries, you should reference points inside a multi-palm, and you don't want to have any problems with shifting IDs, make your own ID system. Don't go extreme on multi-palms, and use JSON instead if you run into any performance issues with multi-palms. It's a lot more efficient with JSON. The only downside, of course, is it's not as good as a visual representation to the end user. Then use the Python module. So don't put everything into the viewer state. And if you write the same lines of code multiple times, make a function for it, put it in the Python module. And then finally, and this is, I think, one of the biggest recommendations I can make here, is steal from SIDEFX Labs. So oftentimes you will end up wanting to create some feature that you know exists in some other tool from SIDEFX Labs. And since you can just go there and look at their code, do it, right? Like if there's something cool that you want to implement, go there and steal it. So thank you for your attention. And I hope there were some valuable things in this talk.
Hello everyone, my name is Christos Stavridis and I'm a procedural 3D artist from Greece. Today I'm going to briefly talk about HEXAGONA, my entry SIDEFX Labs Tech Art challenge where I got first place in the game art asset category. I'm going to do a small breakdown of the project, talk about my inspirations and also the challenges I faced during the process of creating it. So, what is HEXAGONA? HEXAGONA is a fully procedural hexagon-tiled board generator. It was created in Houdini and can be used in any application or game engine that supports Houdini engine to build your own board. It features a set of hexagon tiles to choose as your building blocks, a wide range of parameters for landscape and sea customization, different color palettes to apply, set dressing placement, and user input settings for further customization. The main inspiration for HEXAGONA was Simon Tartar's procedural board game map generator, a similar project to HEXAGONA with a basic difference. This is a generator made in Substance Designer, and the output is a set of textures, while HEXAGONA produces geometry with different attributes and groups for the user to utilize. The moment I saw Simon's work, I was hooked, from the simplistic beauty of the hexagonal shapes to the vibrant color palette he used. For me, it was one of these projects I wish I had done myself. Although I later realized I wanted to follow a different approach centered around interactivity and functionality. At the same time, I discovered Oskar Ståhlberg's work, and specifically his browser minigames Planet and Brickblock, a precursor of his current Townscaper. That is what I wanted to achieve with my board generator, the functionality for someone to create a usable mini-world. So, let's dive in Houdini for a small breakdown of the asset. There are 6 settings categories. General settings for the board itself, for shaping the landscape, including the sea, the color palettes and various modifications, scattering settings for the foliage and the rocks, settings regarding UVs and geometry, and finally some settings for custom user input. Starting with the general settings, we can set the size of the board. Choose our base style shape from 4 different pre-made shapes, the standard hexagon one, the chiseled one, my personal favorite with the rounded corners, and last one with weathered edges. There is also settings for the resolution of the board, and that practically means we have 3 different tile sizes, a small, medium and a large one. Finally, there is an option for flattening the board, but maintaining its color variations and depth. The mechanism that generates almost everything in the asset lies in the landscape settings and is almost entirely driven by noises. We have options to change the scale of the landscape, which is basically the frequency of the main noise. The height scale, which is the amplitude of the noise, remaps the colors based on the height position of every tile. A horizontal and vertical offset for the noise. An option to flatten the sea into a merged geometry while maintaining its color depth. And 2 more options for the sea level and its height offset from the shore. Very useful for creating an environment populated by islands or maybe peninsulas. In the color section, there is a library with different palettes, 4 of which are season themed, a desert and a volcanic one. These colors apply to both the land and the sea. I also included a more advanced way of remapping the palette's color range. Think it like a levels adjustment with 2 sliders for the black and white levels and their wrap position respectively. This is helpful if someone wants to remap the colors for a land with the mountains being more snowy or the sea being more deep or shallow. In the set dressing folder, we have the scattering settings for foliage and rocks. There are 3 foliage variations that depend on change with the color palette. There are options for the range of the mesh scale with a minimum and a maximum value, a height range for the placement of the foliage and the rocks, which also depends on the height position of each tile, and finally some settings that have to do with the way foliage and rocks scatter. There's an option for a more uniform scatter that depends on a density parameter, and one for a scatter that's being driven by a noise. I included some settings that have to do with the quality of the geometry and the unwrapping of UVs. There's an option for bevel geometry, which is quite heavy for a game engine, but can be used for offline rendering. An option to generate UVs in case there's a need to apply a texture either on top of each tile or on the surface of the board. There's also separation of groups to assign different materials for the land tiles or the sea. These options must be used with caution and may be at the final stage of the composition, as they can slow down the performance. Finally, I included some custom settings for the user. For example, there are options to use a height map or color map image. With the use of a height map, the color palette gets remapped based on the height position of its tile. You can also assign custom colors for the board and the base of the tile, the sea, and the set dressing elements. There is also an option to use a custom mesh for the foliage or the rocks that are being scattered. As I said earlier, you can use HEXAGONA either inside of Houdini or in any application that supports Houdini engine. That was also one of my goals for the asset, to be accessible and as user-friendly as possible on any platform. That was also a great challenge to achieve and came with a lot of drawbacks. After a lot of playtesting in different applications, I realized that some of the UI elements, like ramps for example, aren't supported in some of the applications. So I had to restrict the parameters of the UI solely to sliders. And for some parameters, like the color's tonal range and values, it wasn't very user-friendly or clear. For the same reason, I sacrificed the use of splines and boxes to generate content, and instead I went to a full procedural generation through the use of noises. I also liked the idea of having this to work in an offline render workflow and thought it would be nice to have the option of a high poly version. There is a more lightweight version to run in the game engine and a high poly for a more cinematic approach. What I enjoyed the most while creating HEXAGONA was receiving feedback. I found that to be the most important aspect in a creative process, as I discovered different viewpoints and gained a better understanding on how to manage each challenge that arises. I am very thankful for the feedback and support I got from friends, artists and developers, especially from the KiwiNotes Discord server. Without them, I wouldn't probably be here talking to you. I am also very excited as I watched HEXAGONA being recreated and becoming a trend widespread as hexagon walls. It's very fulfilling to inspire other artists as other artists inspire me, and personally, it's the greatest reward to receive. I am very thankful for this invitation to talk about my work, and I hope that you find it informative. So if you have feedback to share, any questions, or you just want to say hi, you can reach out to me on any of the social media you like. Bye for now!
Welcome, my name is Kilian Baur and I'm currently an effects artist at RISE in Stuttgart. I started there as a 3D generalist but quickly learned to love the procedural workflow and the technical problem solving with Houdini and Python. Houdini and Python is a great combination to remove a lot of repetitive work and focus more on important things like making a shot look good. In this presentation, I want to show you why I made the tool, what it does differently to already existing solutions, how you can use it in your own work, and some interesting tips and tricks which you might want to implement in your own scripts. What compelled me to create linked subnets was an issue which appears in production from time to time. It's quite common to scatter objects, create many similar objects, or apply the same node setup to multiple inputs with only minor changes. Most of the time, this requires a lot of manual work, making sure to copy the nodes and insert them into the correct location. For a few objects, this is not a huge problem, but as more and more objects are added, this copy and paste process takes more and more time. The SIDEFX LABS Tech Art challenge was a good excuse to find a way which removes the repetitive work, while also being able to keep specific changes for each object. Also, I'd like to thank SIDEFX for the honorable mention. Out of the box, Houdini already ships with similar solutions, but each one had some drawbacks which made them inconvenient to use. When such a situation appears, one of the most common approaches is to just copy nodes manually. But as I already said, this takes quite a lot of time and you also have to make sure not to forget any one of them. HDAs are almost the perfect solution. They allow for changes which are propagated to all other instances of this node. But often those node setups turn out to be very specific to your current shot and you might never need this exact setup anywhere else. The invoke, compile block and for each loops can also be used, but are generally harder to set up and control individual parameters. The for each loop, for example, has to recook everything if you want to change one parameter, and the invoke only works with compilable nodes. That's why I created a subnetwork which has the functionality of an HDA while only being saved inside the current scene. If you want to use the linked subnets, create a sub. Dive inside and you will see a normal subnetwork like you're used to. If you peek one level above, you can see there's no additional functionality, all of it is handled by Python. The most important parameter is the UUID field. This is a random string of characters and numbers, and it gets randomly generated when you create a new sub. You can also press the new UUID button to generate a new one. If two or more nodes share the same UUID, they are linked together, and you can push changes from one node to the others. If you copy the nodes, you can just enter any UUID that you want or copy it of an existing node. In this example, I give the node a different name, color, and shape, and then I push those changes to all other linked nodes. You can also toggle the Ignore Updates checkbox, and any future push changes will not affect this node. In this example, I changed the node color, and I also added a box. If you push the changes now, the node only finds two nodes with the same UUID. That's because the third one ignores the update. Now, the third node also displays the message that it might not be up to date anymore. If you want to view which nodes are connected, you can just enable the dependency links. Sometimes if you copy the nodes, those connections might not be up to date. You can manually update the connection guides, or they are automatically updated when you push any changes. Now I'm going to add some additional nodes inside the subnetwork, for example a color, to change the color of the box. This color I want to change for each of those objects, so I'm going to promote the parameter using the parameter interface. Also, I'm going to promote the scale. Put them into a custom parameters folder to make sure they are copied to the other nodes. You can see how changing the parameter on the HDA changes the color of the box. In the push settings folder, I can control what happens when I push changes. For example, I can choose to copy the name of the node, its shape and its color. Also, I can choose whether I want to copy the nodes inside the subnetwork and if I want to copy the parameters. For now, I'm just going to copy the nodes. As you can see, the color and box nodes have been copied to the other subnetworks, but the parameters are missing. Now let's copy the parameters. Right now it's set to use the current value. That would mean each of the other boxes would be also red and have a scale of 0.9. But I want them to have the scale of 1 and be white. That's why I use default values. The defaults are set inside the parameter interface. Pushing those changes, you can now see that the parameters are also on the other nodes. I can now choose a different color for each of those nodes and also scale them differently. You can now add new nodes in any one of those subnets. For example, I want to rotate those boxes, so I'm going to promote the rotation parameter. Also note that this copy process will also copy sticky nodes and network boxes. I'm putting an expression inside the rotation so it changes every frame. What this means is that you can copy animations or other expressions like HScript or Python. I'm going to disable any override, so the already existing parameters will stay the same. As you can tell, the colors and scales are still the same as I set up before, but now they are also rotating. In a more complex example, I already prepared some parameters, but the nodes are only in one node. I can copy the nodes, but the parameters that are already set will stay the same. In that way, I can have different variations from the same node setup. Now I want to show you how I would use this HDA in a more complex setup. In this scene, I want to draw an ivy along a curve that I previously drawn. The setup basically starts with the drawn curve, and I resampled it to have a more even distribution of points. Using the curve node, I can then animate it. I use the up and n attributes, which I generate using a polyframe node, to later on scatter the leaves. I also have some additional variation, like random p-scale, so the distribution looks a bit more natural. The leaves are a Megascan atlas, which I trace, resample, and move to the origin. Afterwards, I copy them onto the curved points. Now I want to apply the same setup for 4 different nodes. For this I'm going to use the linked subnet. I'm going to create the HDA and put the existing network inside of it. I'm going to copy the nodes and paste it inside the subnet. Now that the nodes are copied, I'm going to promote some parameters so I can change the look and animation of the ivy. In this case, I promoted the second U parameter to change the animation and also the seed so I can change the randomness on the P scale and other attributes. Now I'm going to create another linked subnet and copy the UUID from the original one. I'm copying the node for each input curve and connect the inputs. Now I'm going to push the changes to apply the same nodes and parameters to all of them. You can now see I have 4 different ivy branches and I control each animation individually. Now I'm going to animate the curve view. I'm making sure that it looks like that the branches are growing out of each other. Now I'm updating the seed for each of those branches to get a variation that I like. Now I want the ability to change how many leaves are generated for each of those branches. For this I can use the resample length. A shorter length will result in more leaves. Now I'm going to promote the parameter and adjust the amount for the main branch. I will change the copy parameters to use the default values. That way the other IVs will stay the same, only the main one will have increased leaves. Now I can adjust the length for each of those curves. The copy process is a bit slow, so I'm going to enable pack an instance on the copy to points. Also, I'm going to add the color parameters so I can change the colors for each of those branches. That way I can tint the colors of the leaves to make them a bit more yellowish or bluish. I'm going to promote the parameters and copy it onto the other nodes. For example, I can make the first branch a bit more warmer and the other one a bit colder. Now there's only one final thing I want to add, and it's the main branch that's a bit too short. I want it to reach to the end of the screen. For this I have a point wrangler and it moves the last point a bit along its normal. I can use this to extend the curve. As you can tell, it was quite easy to add new nodes and edit the existing setup without losing the previously set parameters. Feel free to take a look at the Python code that drives the whole functionality. You can find the Python module inside the type properties or use the added extra source code menu. The function has some documentation and comments to make it clearer what each one does. But these are some useful code snippets that I want to highlight. One of the most used functions is the ability to find all linked subnets. For this you can use the node type.instances method to get a tuple of all nodes with the same type. In this example I'm going to use it to find all other boxes and set a specific color. To copy the nodes from one node into another one, you can use the node.copyItems method. Note that this also moves the network editor into the target node. In my tool I wanted that the network editor stays at the same position, so I saved the network editor path and the bounds. That way I can restore them after the copy is over. To get all nodes inside of another node, you can use the node.allItems method, and then copy all those items. To see how I made the dependency links, you have to unhide the hidden settings. And there you can see an operator path parameter where I save all other instances of this node. I keep updating this regularly, for example when you push changes or manually update the connections. Now that the settings are visible, you can see how I made the message inside the network editor. It's a string parameter which is set as the descriptive parm. This parameter has a Python expression in it which checks which of those checkboxes have been updated. For example, if it's outdating or ignoring updates. I hope you enjoyed my little presentation on linked subnets and learned how you are able to use the tool inside of your own projects. Maybe also you learned some new tricks for your own HDAs. You can download the HDA for Houdini Indie and Laura on the SIDEFX LABS Tech Art challenge, or download this and more tools and scripts from my GitHub. Also, I would appreciate if you follow me on Twitter and Vimeo, where I occasionally post some updates. Thanks.
Hello everyone, my name is Erwin Heyms, and in this video I would like to share with you my universal cutting utility asset for Houdini 19, the Polyslice utility node. Now last year I submitted this asset to the SIDEFX LABS Tech Art Challenge, and I ended up winning 3rd place in the category for Best Utility Asset. I'm quite happy about that, of course, and since then I've continued developing the tool, further stabilizing it and adding much requested new features. So right now I'm ready to announce that I'm releasing version 1.3 for anyone who is interested in this asset, and you can download it right now, and you can find the link down in the description of this video. Now let's not get ahead of ourselves, and let me discuss quickly with you what this tool is capable of. So over here I have a rubber toy, and I'm cutting it up using my Polyslice asset. And it can do that because the Polyslice is able to cut new edges and points into geometry procedurally based on a secondary input. And it can do so while maintaining all groups and attributes already present on the input geometry, which is one of the reasons why I created this asset. Because oftentimes when I'm working with the native cutting tools of Houdini, I run into problems. They do work, of course, but they also have their limitations, and I often have to jump through a lot of hoops to make them work properly. Now, in my case, I wanted to create a single node that was able to do the functionality of all of these assets without having to jump through all those hoops. And that's where the Polyslice comes in. So let's have a look at this example here. I have a simple rubber toy, a simple polygon mesh, and I am cutting it by intersecting it with a couple of polyplanes. I feed those into the Polyslice, and it will cut up the mesh. Now by default, it doesn't cusp the edges, meaning that it will keep all the edges connected. But if I do cusp them, I can then explode the mesh, so you can separate it out. Now you might tell me, but this is very similar behavior to the Boolean swap, and you'd be correct, because this node actually has the ability to use both the Boolean method or the polysplit method to cut up the mesh. But as I explained, the node itself also does several operations to keep the cutting behavior clean and simple, so you don't have to worry about how you feed the data to these nodes. You just feed it to the Polyslice and it will work and do all the work for you. So we have the ability to choose which type of cutting behavior we want to use. And this only scratches the surface to what this node is actually capable of. Because if we look up here, we have the ability to change our input type to polylines. And likewise, we can change the cutting geometry that we're using from polygon surfaces to polylines or even points. Meaning that we can cut up our geometry very precisely with any of these types of inputs. And if we don't want to actually cut our mesh, but only inject new points, we can also choose to change the output type of the node to points on edges only. And in this mode, the tool no longer cuts the mesh, but it does inject new points. So if I look at that, you can now see that anywhere there was a cut before, it now makes a cut, but only on the edges where the cut intersected the mesh. And this is functionality that none of these nodes here actually have, at least not procedurally. Now before I continue, let's go over to the other part of the example file and have a look at the default utility nodes that come with Houdini and how they compare to the Polyslice. So over here I have a set of Boolean nodes, and in this case I am cutting this Boolean object with a grid. Now this does work, and we do get a nice cut in between them. However, if we try to use the Boolean swap with overlapping surfaces, and we rotate it just a little bit off axis, then the Boolean swap will often fail a cut. Plus, the Boolean node can only cut with surfaces, it cannot cut with curves or with points. So we won't be able to use this line here to create a cut on our geometry. Next we have the intersect stitch. Now the intersect stitch tends to generate unpredictable and uncontrollable triangulation. And on top of that, the intersect stitch can only cut with surfaces or splines, and they have to be at a cardinal angle. If you don't provide at a cardinal angle, the precision of the node often fails. So that's another issue. And likewise, we are unable to cut with points because those points aren't actually added to the geometry. And finally, we have the polysplit. And the polysplit is a manual node. Usually you can use it in the viewport. But if you try to use it with its secondary input, then it doesn't always generate clean cuts. So that's another issue. So that's where the polyslice comes in. What I try to do is create situations like up here, where these nodes will fail, and then fix the problem to create a proper cut without generating bad geometry. And if it will still try to do that, I try to provide the controls necessary to correct it. So down here, once again, I have my two overlapping boxes. And in this case, if I run them through the polyslice, with cutting geometry set to polylines, then the edges of the second box are going to cut the first box, and no matter what orientation I put this box in, it will always work. So this is actually a pretty secure method. Moving on, we can also use edges in order to cut our objects. So over here, I have another box, and this one is being cut by a series of edges that are overlapping the mesh. Now the tool has a snapping feature, which we can access down here, which allows us to determine how far a curve can be away from the surface before it stops being detected as a cut. And you can play with the snapping distance to allow your tools a bit more precision when you're trying to make cuts with imprecise input geometry. Like for example this curve. It doesn't quite overlap the surface, but it's still able to make a cut. Furthermore, the polyslice will always try to make a complete cut. It cannot actually make a cut that ends in the middle of a geometry. It always has to connect to another edge. Now, by default, the tool will not prevent you from making these cuts. However, you can turn on Prevent Incomplete Slices, and when you do that, it won't allow these kinds of cuts. And like I showed you before, we also have the ability to not make any cuts and instead only inject points on edges where our cutting geometry intersects. So if we turn this on to points on edges, we won't have any cuts, but we'll still have our cutting points. And then over here, I have another example where the snapping feature is used to make sure that even though these two surfaces are not quite on top of one another, this second grid here is still able to cut the first grid, even though they don't perfectly overlap. So the snapping feature is actually quite powerful, again, when you try to use it procedurally inside your tools. And then next, let's have a look at this example, where we have the same situation as up here with the intersect stitch, where we have a grid, and in this case a line, and these are overlapping. However, in this case, the polyslice is able to properly inject a point from that line, even if it's not quite aligned with the grid. And likewise, if we grab the convert line node here, basically turn this into a polyline object, and then we make sure we turn the tool into polylines cut with polylines, then you can see we can still inject points even if this isn't the surface, but just a couple of splines. And then finally, we can even do this with points. So in this case, I have a point over here that's being injected onto my spline, and because of the snapping feature, it's able to inject it into this line and cut it up, which is not a feature that any other node in Houdini has out of the box. So as you can see, the polyslice is a pretty powerful node capable of cutting geometry in any configuration that you want to use it in. Now to finish up this video, I'll quickly show you a couple of practical examples on what we can use the polyslice for. So over here, I have this floor plan, and it actually starts out as a simple curve, just a simple spline that I've drawn, and I overlap it with this shape here. If I use the polyslice, I can then cut that into my geometry. So over here you can see we have a clean cut. I then use this group node here to group the internal area as a corridor, and then I run it into a second polyslice, which gets a couple of additional curves, and those curves overlap my corridors. However, I'm also using an exclusion group here, a mask if you will, to specify what part of my mesh I want to cut and which part I don't. And even though these edges don't completely cut the corridors, we still end up creating clean cuts over here. So if I grab this point and drag it around, you can see that the edge isn't disconnected. And that's because inside of the poly slice, I have this feature here, the slice edges neighboring the source group. And if you turn that on, then it will make sure it also cuts the meshes that were excluded from the cut itself. So if I were to turn this off and I grab this edge, then now this will actually be disconnected and leave an opening. So using this toggle here, we can make sure our edge stays clean, even though it wasn't actually part of the cut itself. Now we can also use this group here for our cutting geometry as well. So over here I have a different example where I'm adding points into my surfaces, and I'm using these points over here. Now I do have one point marked as no cut, and in my geometry I've specified that I don't want this group to be used. So right now we are only adding 3 points to our mesh, and as you can see, these are also grouped, and I want to use these points later on to place pillars into my floor plan, so I've marked them with the supports group. And then finally, over here I have some boxes which are intersecting the edges of our mesh, and I'm using the cut points into edges mode in order to only cut points on these edges. So I can basically mark off where some doors should go. So in the end, I only needed a couple of nodes and a couple of inputs to quickly create a proper floor plan for whatever building I'm trying to create. So that's pretty useful. But let's have a look at a different example. So over here, I have a SIDEFX logo and I have a grid that's moving on top of it. And I've animated this grid, as you can see, as it moves over the SIDEFX logo. These edges are being cut up, and I'm adding a group wherever this mesh intersects. And then moving on, over here I have a couple of curves that are being cut against one another, and depending on the distance that they are from one another, they create a cut. Now, let's say I overlap them perfectly. In this case, it will make a cut wherever they intersect. Now, the tool itself doesn't actually combine two objects together, but we can run it in a loop and then process each one against the other geometry, and then it will create proper intersections. And then finally, I quickly want to show you some of the precision controls that we can also use. These are some of the more advanced settings on the node. So you can use these if your cuts aren't quite doing what you expect them to do. Now by default, I've enabled the auto precision correction system. And this is a feature that prevents you from giving it really high values or values that will generally break the result, and it will automatically correct them to something more reasonable. And it uses the input geometry as a guide for that. So if I turn this off with my snapping distance set to 100, this curve will practically disappear. And even if I set it to a lower value, it will probably snap itself into a much more raw shape, something that we don't want. So the auto precision correction will help us from creating bad geometry by using nonsensical settings. And also for other more complex types of geometry, we can also use this for example, where we have this waveform with a really dense set of points that are being cut into this mesh. So this actually started out as a very spiky shape, and this was submitted by one of the testers of the tool. And in his case, he couldn't get it to work with this shape here, this waveform of sorts. And he wanted this to cut up the mesh. Now I've since updated the tool with the auto correction mode and the new Boolean cutting feature to be much more accurate than it was before. So with version 1.3, these types of shapes are completely possible to make. We can also do this with the other modes as well. So in this case, I'm cutting a polygon surface with another one, and I'm using the Boolean shatter method to do this. Like I mentioned, this mode is faster because it uses the power of the Boolean node. But we can still use the other modes as well. So if I switch it over to the poly split, it will be slower to compute this, but we can still cut the geometry. And in this case, the precision mode down here is actually being used to make sure this works properly. And finally, let's say we want to use a polyline instead of this surface here. And we can still do that. If we feed this to our mesh, then we can still cut it out. Now, of course, if you want to know more about the settings of the node, then you can always check the help file as well, which is included with the tool. And in here, I've summed up all the features of the settings in the node, so you can always find out what something does by checking out this document. So at this point, I think the tool is as stable as I'm going to get it. Now, it might be possible I will upgrade it a bit more in the future, try to make it a bit faster, fix some bugs. So thank you for watching this video. At this point, this tool is pretty much ready, and I'm going to distribute it right here in the link in the description down below. Now, the reason I created this tool was to use it in future chapters of my masterclass. But I'm sharing it with everyone because I'm hoping that this tool will eventually be added to Houdini or the SIDEFX Labs toolkit. And I wanted to make sure that it was as stable as possible. Now, I might make some changes in the future. I might try to speed it up or fix a bug or so. But for now, I think the tool is ready. And if you have any comments on the tool, or if you want to tell me how you're using it, feel free to leave a comment down below or join me in the eHoudini Academy Discord channel. I would love to see how you end up using this tool for your own projects. So thanks for watching this video and have fun cutting your geometry. Have a good one.
大家好，我是来自中国的一名技术美术师，我拥有多年的胡迪尼使用经验，之前曾供职于 MPC 等电影公司。现在我将介绍一下我的一个小型的程序化白光系统。首先我们可以看一下这个在编辑器里的效果，这是我用工具生成一些简单布局的植被，包括远处有一个长满了树的球，还有一个圆锥体附近长满了植被。首先我的目标是能够将所有的数据类型给统一，不管是定型还是 geometry，其次是将参数和具体执行逻辑分离，使用两套 HDA， 一套是负责管理参数，另一套 HDA 是负责执行具体功能。最后是利用 PDG 将以上数据参数功能进行统一的管理。首先需要确定的是数据格式和序列化规则。我们把数据叫做 layer， 然后地形数据使用的是 PNG 格式，非地形数据使用的是 BGU 格式。序列化规则是以 layer 名作为文件夹，然后以 tail 作为文件名作为文件名。可以看一下。我这里有很多的 layer 层，有33个，然后我们可以点进去看的话，它每有一个文件，然后这个文件的话就是一个 tail， 然后就是以这样的一个形式来管理我们的数据。接下来的话我会先 确定一下数据的类型。首先这一块有一些是地形自身的一些特征的数据，有一些是基于 noise 或者是 pattern 的数据，还有一些是几何体自身的数据。我们打开例子可以看一下，就比如说这个 HDA， 这个 HDA 的话，它是可以去读取这个几何体，然后在这个几何体的附近去生成一圈影响交互的东西。我可以调一下参数看一下。就调到500，它这边会自动的根据规则去重新生成这个 layer。我现在把它调回去。然后这一层的话，它是可以，这一层我这边输出的 layer 名字叫 noise A。这一层的话，它是可以简单的可以去生成一些简单的 noise。我这边调成参数，这边就会实时的去生成。然后把它调回来。然后这个节点的话，是单纯的去读取几何体，然后把几何体输出。因为我们输出的类型是 mesh， 所以说我们会把它给保存为 BGO 格式。然后这个节点的话，主要的是去读取地形，然后生成一些地形自身特征的一些 layer， 然后这边都会输出出来。还有一种数据是需要人工的去指定的，比如说我需要去通过笔刷的形式去在地形上面去刷一些数据。还有一种是需要将数据进行一个拼装融合之后产生的一个新数据。我们可以看一眼。这是 UE 里面的一块地形，然后我这边的话是做了一个笔刷，我可以在这儿重新创建一个新的层，叫 MYB， 然后我修改一下颜色，然后我点一下 Print 之后，我就可以开始绘制了。比如说我在这儿绘制一个形状出来，然后我点 Save， 然后我再把它给输出，然后我们这边就会有一个 MY 的层给输出出来。然后我们接下来看一下这个笔刷的一个实现原理。首先的话，我们是需要将参数这个 layer name 的两个 layer name 给创建出来，初始化一下。我们这边是初始化了这两个层，然后将这两个层与之前的层合并一下。然后当我们点 print 的时候，我们这个 plus 它会自动的去将当前的给筛选出来，当前的层筛选出来。我点这个 MYB 的话，它这边自动的就会变成 MYB， 然后通过Houdini自身的笔刷，我们就可以开始绘制了。绘制完之后， 需要将 MIB 这个层复制过去，然后我们现在就可以得到一个所有的最新的层。然后我们点 Save 的时候，会执行一个脚本，然后将数据储存在这个参数里面。储存在这个参数里面，这个参数类型是一个 data。储存在这个参数里面之后呢，这个 stat 值就会 link 到那个参数，然后在这边的话，它就会读那个参数的数据，也就是这个操作，也就是将刚才上一次的结果给读回来。读回来之后，我们就可以去实现这样的一个效果，就是我点这个 print， 它就可以加载上次的结果。我点这个的话也是一样的，它是可以加载上次的结果。这就是它的一个实现的原理。第二个需要说明一下是这个层编辑的 HDA。我们可以看到的话，就是我这边是导入了2个 layer， 这2个 layer 是在之前已经生成过了，一个是 operation， 一个是 MIA。然后我在这边创建了一个新的层叫 combine， 然后通过一个这样的表达式将这2个层运算结果复制给这个 combine。 我们可以看到是这样的，我点这个 go catch 的话，它就会去输出出去。然后每一个这个 reference layer 的话，我们是可以去调整它的 ramp。我们新创建一个 reference layer， 然后我导入 noise A 吧，然后 new name 这我要写一下，然后我在这儿修改一下这个表达式，就可以看到这是我最终的一个效果，然后可以去调整它。随便调一下，大概是这样，然后把它输出，然后最后结果它会被输出来。这个实现的一个原理是这样的，首先它会将所有的层都会导入进来，之后的话是需要给每个这个 ramp 进行一个vex 的重建。第一步需要使用那个 Python 将 ramp每个点的一些数据给记录下来。然后我们这边是可以生成了这3个属性。拥有了这3个属性之后，它就是可以完整的去描述一个 ramp 的完整的去描述一个曲线的形状了。然后我们用这个 spline 这个函数在 vex 里将这个 ramp 进行重建。这样的话我们就可以得到一个经过 ramp 处理后的一个3个层。最后就是将这个表达式的内容直接复制到我们这个节点上就行了，然后它就会进行一个运算。然后在这个例子中我们可以看到这里有一个尾号是0和1的。这个需要说明一下的是， 我这边 reference 进来是有两个一模一样的层，叫 height， 然后我的 new name 是不一样，就等于说我这边是同样的一个 reference layer， 然后变成两个不同的版本，因为我需要它们来进行一些操作，就比如说是这样的。然后是介绍一下这个参数列表。我这边的话是，使用了一个 HDA 来管理这个参数。这个 HDA 它会执行生成一个 JSON 文件，然后这个 JSON 文件里面包含了我所有实际功能模块的参数。然后当我删除这个 HDA 的时候，它也会对这个 JSON 文件进行一个删除操作。那我们可以看一下Zhang中的一个演示情况。可以看到我们这里有六个参数文件，对应的是这边6个，这边6个。然后在这边每一个 HDA 里面的这些参数，对应的是我后面它对应的其实就是一些实际的一些具体的功能，但是这个 HDA 它内部它并不包含这些功能，它只是一个参数的写出。我们这儿复制一个新的，可以看到我们这边也创建了一个 JSON 文件，然后我们可以对这些参数随便进行一些修改，比如说对它进行一个修改，随便改一下。我们打开这个文件可以看一眼，这里面包含了所有参数。然后打开胡迪尼看一眼，就这个 HDA 的话，它实现起来特别简单，就是在创建这个节点之前，我都会运行一段 Python 脚本来创建一个 MD5， 然后把这个 MD5 当成一个唯一的一个 ID， 然后将这个 UID 写到我的全局的一个属性，然后将这个 UID 作为我 JSON 的名字写出去。写出之后就当我们这个节点被删除之后，它同样会运行一段代码来进行一个 JSON 文件的删除。我们可以看一下，我们将这个 B2 节点删掉，它这边也会被删除。然后我就开始准备使用 PDG 来管理任务和创建任务。首先我们看一下胡迪尼。我会先读取这个文件夹下面的所有JSON 文件，然后开始解析这每个 JSON 文件，将参数解析出来。参数解析出来之后，在这边我会将参数过滤出这3个属性，这3个属性是我想要的。然后这个 brush 它代表的是一个 layer 的名字，像这个没有的话，它其实读的就是那个 BGU， 这是一个 layer 名字。然后将这些全部合并完之后，然后在这边会根据 根据类型，左边这两个是负责处理 PNG 的一个镜，右边的话是对 BGO 进行一个处理。它这边是一个它会创建一个路径，然后将所有属性进行合并。在这边的话就会根据路径把所有的 layer 都加载进来。我们这边就把所有需要的 layer 都加载进来，然后还有一些集合体都加载进来，然后再进行输出。这边的话是进行了一个同样的操作，也是把那个参数给解析了一下。这边都解析过之后的话，它就会在这边创建任务。这边的话我就创建了6个任务，然后每个任务都会执行这么一个biome scatter 的一个流程。它这个就是一个它就会运行实际的一个运算逻辑。可以看到这是根据一些不同的需求来产生的一些点云，然后将每一层给输出，输出完之后我们会在这边做一个合并，会根据 tail 做一个合并，就是每个相同的 tail 的所有数据都会进行合并，合并完之后会走一个后处理的流程。这个后处理的流程它其实是做一个，它就是为了实现一个功能，就是比如说我想植被 A 去剔除植被 B， 我需要用 tag 来做一个标记。因为我们之前所有的运算逻辑都是并行的，它们任务与任务之间它是没有关系的，所以说为了去实现任务之间的通信，我这边的做法是给每个植被打上一个标签，然后根据标签来进行一个剔除操作。这边做的就是这个。然后现在的话，它就会把结果给输出到引擎里。然后最后的话，我们是将所有具体的那个功能进行一个模块化的处理。就是在这里 biome scatter 这儿。这边可以看一下，就是我会把所有的用到的 layer 都加载进来嘛，然后根据一些需求，根据它的需求，我们会把它给删除出来，然后将我需要的那个 layer 生成那个删除出来之后，把它 rename 成 mask， 这样方便后面处理以及可视化。然后 这个 scatter 的话也是会进行一个类型的区分，因为我们这边有一个 source type， 它这边的话它是这个 source type， 对，这边的话是由参数告诉我们这个我们应该用什么样的类型进行一个撒点。现在基本上是有3种类型，一个是基于图片生成，基于图片，还有一些是基于geometry 的，就直接在那个物体上撒点，还有一些是基于点的。然后这个节点的话是处理碰撞的，就在这儿的话，我们是可以去控制一些碰撞，比如说我们可以去剔除离自身特别近的一些点云，然后还可以去剔除一些别的参数列表，就比如说我想剔除这个 rock 的话，我这边只需要将这个 tag 写进来就行了。这样的话，这个 rock 就会把我这个 class 给剔除，就是在这个距离内，它就会被剔除。这个模块就会实现这么一个功能。然后这个 bound geometry 的话，主要实现的是在这儿，它是可以读取任何多的instance， 然后每个 instance 它都是可以去设置权重，然后有一个 size 的属性，这个 size 的属性它是可以去影响这个权重，然后还可以去控制一些随机的大小和随机的旋转都是在这个模块里面去实现的。就比如说我们这个权重的设置，主要依靠的是这一个函数来实现。我这边只需要提供一个权重的列表，然后提供一个random 一个随机值，它就可以将一个权重的分布给计算出来。后面的话只是一些后处理，就是一些将打上一些 tag 呀，或者是去做一些输出前的一些准备，将属性转换一下等等。然后我们这样做的一些好处的话，就是我可以将各个功能就将这些功能模块化的好处就是我可以特别方便的去扩展，然后每个功能我也可以随时关闭或者是打开，这样我也比较方便的可以去做一些debug 的操作。这套系统它允许你可以通过非常多的手段去生成 layer。这边的话，你看我是有好多种 HDA 去生成 layer。你还可以在Houdini里面去创建一些自定义的笔刷，你可以去创建自己的笔刷，或者是自己的工具来生成 layer。也可以在别的一些 DCC 软件或者是在 PS 里面你去创建 layer。 甚至你可以在 Web 里面自己去画一些 layer 都是可以的，不需要有什么限制。然后这边的话，参数这一块的话也是会非常轻量级的一些功能。然后我们这边也不会去，就当你调参的时候，它也不会去执行具体的逻辑，也不会有卡顿，也不需要去关注它的一个在胡尼中的一个节点的一个连法。就当你拥有了这2个部分之后 ，PD 机就会按照规则去创建任务，然后并且去执行任务。这边的话我们可以试一下，现在的话植被都被删除了，我们可以执行一下。自动的去帮我们创建任务，特别省心。OK， 这结果就生成了，可能10几20秒吧，整个流程跑下来。然后可能在效率方面的话，不如直接生成，就常规的那种直接撒点生成来得快。去做一些比较小型的一些项目的话，会比较好一些。好了，我的演讲说完了，谢谢。